international think and do tank for circular economy practitioners with about 500 members from the private sector, academia, civil society, and public institutions. So we are really about bringing different perspectives in the field of circular economy together. And the Prevent is a platform for especially technical knowledge exchange and international cooperation. The network was launched in 2019 by the German Federal Ministry for Economic Cooperation and Development. And one of the topics that was really demanded by many of our members was the topic on alternative plastic materials, to dive deeper into that discussion. And that's what we are doing with this webinar series. If you would like to learn more about the Prevent, you can find the link to our website here in the presentation, or you can always feel free to contact either Silke or me, also via email. We will post this information in the chat also, so you can just copy it. And as I said, we have been starting this webinar series in alternative plastic materials by the end of last year, with a rather general session on the terminology and the challenges and opportunities of alternative plastic materials in general, to really get everyone on the same page and to really start the discussion within the Prevent. And we thought that we couldn't take this discussion if we don't cover all the different steps in the value chain, because there are different questions coming up for each of them. So in the first session, we also focused a bit on the production processes. And now we would like to continue with the second session on the use phase of alternative plastic materials before diving deeper into the end of life in the next session. And with that, I would like to hand over to Silke. You're still on mute?
Muted. Okay, I got it. Thank you, Annika, for the preparation and for all joining this second webinar. But before we start to dive into today's topic, I'd like to give you a short recap on the first webinar, which is also available on YouTube via our Prevent channel. And this can be or will be posted here in the chat by Annika. So we had a great introduction on terminology and a market overview by Sophia and Alexei from the Impala Hub, who concluded that there is a huge market opportunity to replace fossil-based plastics and reduce carbon emissions as the same. But also it was clearly confirmed that countries need to work together to tackle trade barriers and remove incentives that keep the playing field under fair conditions for plastic or unfair for plastic substitutes. And they also mentioned that the cost of feedstock makes up to 60 to 70% of the total production cost of bio-based materials. In our second contribution last webinar, can you click further, Annika? We had a presentation from Angeliki and Philipp from the Institute of Polymer Engineering of the Fachhochschule Northwest in Switzerland, which gave an overview of types of different biomasses used to produce biosourced materials and showed processing methods, but also gave an overview on the application of biosourced materials. And in this third contribution last webinar, Anna who is active in Gaia, in this NGO, and in NIPFADIO, she was talking about challenges and opportunities of alternative materials from an NGO perspective. And she clearly stated that bioplastics are part of the solution to the plastic crisis, but only if the right material and right design are applied correctly to the right problem. And she pointed out challenges as the overproduction leads to a pattern on injustice, and the material substitution shadows the need for systemic change. Also, she highlighted the inability to handle new waste streams and the inefficiency of the current waste management systems, which need to take into account while we are talking on alternative plastic materials. But she left not without recommendation to work further on transparency, to work on a systemic change, but also address injustice patterns and focus on reuse systems and implementing a zero waste strategy. For today's second webinar, we are looking at the use phase, as Annika said, and their economic viability of these bio-based and biodegradable materials under local conditions. And for this, we have, as a start, invited IMplus to talk about practical insights of alternative plastic material applications. And I'm very happy to introduce Pablo and Giovanni from IMplus to you. Pablo will start the presentation. He holds a PhD in chemical environmental and process engineering from University de Valencia in Spain. And he has been working as a researcher at IMplus since 2019. He's leading the biotechnology group, and his expertise is focused on anaerobic biodegradation, fermentation, and on the enzymatic and microbial and enzymatic degradation of plastics for the obtention of biochemical products of interest for the plastic industry. And Giovanni has also a PhD and is working on plastic biodegradability and compostability. He did his master in environmental engineering at Politecnico di Bari and obtained his PhD in 2023. His PhD thesis deals with the sustainability of cellulose-based bioplastic in the current waste management system from a technical, environmental, and economic point of view. So he also was involved in several national projects and worked in a municipal waste management project in Southeast Asian countries under the EU project SWAP. So that's a long introduction, and we are very happy to have you here as experts, and we are looking forward to your contribution. The floor is yours. Yes.
Okay, thank you for the introduction and for the opportunity to be here. I'm going to share my screen now. Okay, going to put the presentation mode. Now you can see the full screen. Okay. Okay, so well, thank you for the opportunity to be here. You have also our email address in case of any doubt, and you have our contact here from mine and from Giovanni. And we're going to start the talk with the definition of bioplastic that we know that we saw it in the previous session, but it's important to remind that bioplastic is defined as
en Bitcoin. Como ya lo saben, durante todo este año 2024 estoy realizando este nuevo desafío.
Okay. So bioplastics are defined as plastics that are biodegradable and plastics that are their origin is biological, are renewable from renewable materials. So here we consider both types of plastics, the biodegradable ones and the bio-based ones. Okay. And from the why bioplastics are used and are increasing the market and they are increasing the value in the market. One of the reasons is the resource scarcity, the increment prices of fossil fuels and fossil-based materials. Is important to remind this crisis that we have. And also this together with the plastic pollution that we can see practically everywhere is they made an important increase in the environmental awareness of the society. All of this together with the bioplastic properties such as the biodegradability, non-toxicity, and their sustainability are some of the key factors for the market growth of this kind of biopolymers. As we can see in this graph, we can see how it's expected to grow the market of bioplastics according to European bioplastics, and is an exponential growth in the global production capacities. So these are the main reasons for the use and the growth of the bioplastic markets. Okay, so well, as we have seen, the market is increasing and increasing every year, and regarding the applications, we can find bioplastics in practically every application, from packaging to electronics, going through automotive, agriculture, and textiles, among others. Also, it's interesting in the applications. The most used application in bioplastic is the packaging, reaching the 50% of the total bioplastic market in 2023. Okay, but as we are mentioning, the final we can divide in bio-based plastics, bio-based bioplastics, and biodegradable plastics, and depend on the characteristics and on the specifications of each application. We will find more biodegradable or more bio-based, or depending the final application. So here we can see how the agriculture in the agriculture applications, the products are mostly biodegradable biodegradable materials, because the products are not going to be collected after their use. So their end of life is mainly the biodegradation in soil conditions. So for this reason, here we have in agricultural applications the more biodegradable materials than other one. Also, in other applications such as building and construction, automotive, and transport, here we the characteristic of biodegradability is not desired, because the building and construction is not necessary, and we don't want that it biodegrades quickly. So for durable products in these applications, we don't need this characteristic, and for this reason, the main polymers are bio-based polymers, but not biodegradable. And in the case of the packaging, we have to take into account two different factors. If the product is meant to package any kind of food or organic substances, the biodegradability could help to the final disposal of the product in, for example, composting or anaerobic digestion. But if the packaging is not contaminated with this organic waste and its recycling is feasible, in that case, bio-based could be also a nice option. So for that, we have to take into account the application to apply one type of bioplastic or other. Okay, from the economic perspective, here we have an example, a PHA case where it is compared the production of PHA from the urban by waste, from municipal food waste, and compare the production with traditional polymers like low-density polyethylene and polyurethane. And also is compared with PHA that is produced from first-generation biomass. So from PHA produced from crops production. The feedstock is the crops. So here in this paper, it was analyzed different options, and all of the processes are integrated and contemplated in the study, including the final and the end of life of the PHA, and also the valorization of the waste or byproducts that are produced during the PHA production. So the main conclusion from that studies, this study, is that the most relevant contribution to the cost for the production of PHA from urban by waste is that the most relevant contribution to the cost is the source separated food waste in the biorefinery. It takes more than 75% of the budget cost of the biorefinery plant, which is agrees with what it was said in the previous session, that 60 to 70% of the cost for the production of bioplastics is related with the feedstock. So this is an important point, and then we can see that is a challenge, but it's also an opportunity to improve here in a local context. Also, incineration it has a relevant cost for the valorization of one of the byproducts during the PHA production, and also the digestate final disposal has to be take into account for in a local context. Then we can analyze better this digestate final disposal, and also it's not a relevant contribution, but it should be highlighted that management of the PHA waste is negligible in that case. So finally, comparing the cost for the different PHAs and the traditional polymers or fossil-based polymers like polyurethane and polyethylene, we can see that the PHA produced from food waste from different municipalities, the different cities were analyzed, like Barcelona, Lisbon, or Trento. We can see how the cost of the production of PHA was ranging from 0.6 to 2 euros per kilogram. If we compare this with the PHA produced with first generation biomass, it is an improvement because the traditional PHA now it has a cost of 3.1 euros per kilograms, and also the local context is favored from the comparing the results with polyurethane, which is the PHA from the local context, from the food produced from food waste. It was it has a lower cost than the polyurethane. In the case of the polyethylene, it is not as clear, but some if we achieve to reduce the source separate food waste, it could be that the price of the PHA is going down and achieve a good perspective from the PHA produced from food waste from different municipalities. So this is about the economic perspective, and regarding the regulation and recommendations, we have set different the recommendations, and one of them is the prohibition of label with generic environmental claims, which do not provide clear terms and can lead to confusion. And also, especially important is to specify where a product is biodegradable, because it's not the same to say a product that it can be biodegradable at composting conditions, but not at in soil conditions. So something that we need to avoid is the use of labels with generic environmental claims. And for that, we have an article in the Article 8A from that directive, says that the Commission shall adopt an implementing act laying down the specification of labels or marks to ensure union-wide recognition of biodegradable and compostable plastic cover bags. Okay. Also, the European Commission has recognized the important role of bioplastic in climate neutral and circular economy. Okay, and regarding the labeling, we have in Europe the industrial compostability scheme, where we have the labeling for the industrial compostability, and for that we need to have or we need to reach different considerations regarding the chemical characterization, the biodegradability, obtain a higher biodegradability of 90% in 6 months, also the disintegration assay, and the ecotoxicity. Also, for the regulation, as we have mentioned before, depending on the application, we need to use one bio-based polymers or more biodegradable polymers. So in that context, for agricultural products and fertilizing products, it's going to be a new regulation in Europe to promote and avoid the use of non-biodegradable polymers in soil and release the microplastics in the soils that can remain in soil. So for that, we have collaborated with the European Commission to set some criteria regarding the biodegradability in soil conditions for these products, for the fertilization products. And regarding the challenges and opportunities in the local context, one of them is the feedstock availability. For example, local agricultures could provide bio-based feedstock for the production of bio-based plastics. The waste management performance is really important. As we have seen, one of the most important costs for the PHA production from urban bio-waste is to have quite well separate this urban bio-waste. The market access, also cultural attitudes is really important. The environmental awareness of the society. Also, local regulations are really important for that. to include and to provide to promote good practices with bioplastics. Also, the climate sustainability is important, taking into account the availability of feedstock recoverable depends on the climate that characterizes the local context. Also, the education and awareness of society is really the most important thing. And the processing facilities, the availability of processing raw bioplastics or treatment plants to treat this kind of waste are crucial for the development. And coming back to the PHA case, here we have pointed out that the most important cost for the PHA production from urban bio-waste, it was the source-separated food waste in the biorefinery. So good practices in the collection and sorting could reduce this cost. So if in a city could implement these good practices, could favor the biopolymer production from this urban bio-waste, and also the local citizens could be favored due to the employment increase related to the circular bioeconomy. Also, the digestate final disposal is another crucial cost that could be favored from local regulations inducing to use of that digestate disposal to for their use in the local agriculture, using it as a biofertilizer. So these are the main challenges and opportunities that we have seen in the bioplastic world in the local context. And well, thank you for your attention. And if you have some question, now we are. It's a pleasure to answer you, me and Giovanni. So thank you.
Thank you, Pablo, for this overview and this in-depth study. And yeah, as I said, we will allow 1 to 2 questions before the pitches of the startups. And Piotr is asking, I'm not sure if you want to ask your question yourself, but otherwise I would read this. He is asking, it's interesting to note that there are biodegradable fossil-based plastics. It was a mystery for him. So is it true that it's well biodegradable and fossil-based, that this is possible?
Yeah, there are some plastics that are fossil-based, but because of their structure, can be easily biodegradable. One of them is the polycaprolactone. It has a fossil. It's a fossil-based bioplastic, but it can biodegrade quite well.
Thanks. And does your data are they only for Spain or where? No, I don't think so.
No, the data from that paper were from Spain, but they analyzed other, more concretely, they analyzed Barcelona city, the Barcelona context, but they analyzed other cities across Europe. They analyzed, I thought it was Copenhagen, you can check it. It was Copenhagen, Lisbon, South Wales, and Trento.
Yeah, and if I add just one short thing, the data presented at the beginning of the PHA context related to the production and use of bioplastic that were associated to a global trend and are free data available in the European Bioplastic website.
Yeah. Nicola is asking, what about starch-based polymers? I think there are some applications later on starch-based polymers, but if you have a short answer. or we can discuss this also later.
Yeah, well, I'm not sure what is.
I think that's a question for later,
Okay.
Nicola. I think we can get into the discussion on the different sources and different kinds of biopolymers at the later discussion. So I think, no, okay, then Piotr is also asking if he understands as well that the biodegradability standard EN 13432 you are referring to in your presentation is not stringent enough from your perspective.
Well,
if I can answer, actually the norm involves 4 main pillars. So it's actually cover most of the important things related to the end of life of bioplastic in compounds. So first, the bioplastic should not contain at the beginning any hazardous or a potential contaminant like heavy metals, and so it should be produced by like material that have volatile solid content higher than 50%. So like the norm itself try to ensure that the plastic will not be a problem at the end of life. The question is sometimes if the actual norm is reflecting the operational condition in the facility plant, and these the standard entity are working every year on it. So like they are trying to make it as near as possible the standard to the reality. But like just to reply to this question, the norm covers at least the technical part that the bioplastic should ensure, not be toxic as material, actually biodegrade, that not have an effect on the compost and so.
Thank you, Giovanni. So I would hand over to my colleague Annika, who is introducing or shortly giving the floor for the next steps of the webinar.
Yeah, thank you very much. And yeah, thank you very much for this really insightful input. And now after the first input, we would like to hear some practical experiences from bio-based and biodegradable plastic producers. So they could share their experiences and opportunities and challenges from local conditions. Yeah, and we are really happy to have 4 pitches now. The first from Natupla by Catherine Carrillo from Colombia. Then we have Jose Espi here from B0, so showing a local experience from Spain. Then we will continue with Nori from Biopack from Indonesia. And last but not least, Anmol will present Bank biopolymers. Yeah. And I would like to give the floor to Catherine now.
Thank you, Annika. Hope you can hear me well there. Good.
Yeah, we can hear you.
I'm gonna share my screen now. All right. So thank you for the presentation. It was really insightful, also as an introduction for everything that I think all of the 4 companies are going to be speaking. My name is Catherine. I'm the co-founder of Natupla. We are located in Colombia. And today I want to show you or share with you a bit of what we have been working over the past 2 years. I first would like to change a bit the setting of what we think about plastic, saying that plastic is really amazing. And perhaps like at the beginning of this kind of presentations, you expect people to say that plastic is really bad, but in reality is that the combination of the properties, the properties that plastic has and its low cost have made plastic one of the most amazing materials over the last century. So I believe that without plastic, we couldn't have been where we are at this point. But unfortunately, it has created a huge disbalance problem, and I'm gonna share with you a bit about that. As Pablo was mentioning, there is like a problem on the source, and because plastic production is responsible for 3.3 of the whole global emissions of the CO2 production. But then we also have a problem at the end of the way plastic is being disposed, because it is polluting. So in countries where waste management systems are not really well in place, the mismanaged plastic can end up accumulating in the landfill or on the water sources. And beyond that, and I think also Paulo mentioned it during the presentation, there are plastics that have problems with recyclability. There are like complex materials, there is lightweight or dirty plastic that, depending on the waste management systems in the country, cannot be easily recycled or is not cost effective. So what we do is that we focus on designing biomaterials, and we do it from the perspective of how are they going to be used and how are they going to be disposed. So we focus on developing bio-based and compostable materials, especially to replace those hard to recycle plastics. Our solution is bio-based. It comes from renewable resources, but we also integrate some agricultural byproducts from the cacao or the sugar cane, agri-waste here in Colombia, and of course some different polymers and additives that Pablo also just mentioned during the presentation. For the disposal, we focus on home compost mostly, but our products can also be industrial compost. They can also be recyclable, which it is important for the process of this kind of materials, as there is no losses during the processing or the molding of the plastic. And also we have products that are biodegradable in soil and some other ones that are biodegradable in water. So these are some of the products that we have developed with our materials. So we have work on blown film extrusion, and we have also tried our material for injection molding. And over the last couple of months, we have been also working on their coating for fertilizers due to the regulation changing. I think the opportunities of bioplastics are huge. These are like some of the cases we have been testing with potential customers for dog toys, lollipop sticks that are difficult to recycle, bags for waste and cup sleeves. And these are like some of the different products that we have developed, like focus on the compostability of the for film extrusion. Also, we have a product that is soluble in water that can be used for products where people don't want to be in touch with, or that can be highly volatile. We have also a product for injection molding, and the other product where we also use agricultural residues from the industry. I think there are like several alternatives, and of course when we go into the technical details of our product, we will need to analyze where the product could be useful depending on the tensile strength and the MFI. But what makes us different is that we strive for a competitive price. So we believe that sustainability shouldn't be only for a niche market. Therefore, we develop products that can be offered at a competitive price, even when comparing them with products that are currently in the market. We believe also that materials should be sustainably designed. So meaning that we create materials for what they are needed, and we think about how they are going to be disposed. So in that way, we can also find the best combination of materials and the characteristics that the material should have. And we work under the principles of green and sustainable chemistry. And finally, well, I think is, as I said at the beginning, like reaching plastic will be difficult because it has really good properties. But what we try is to be similar to plastic in the way that our material can be processed in traditional machineries and that can be recycled to avoid any waste. We have our R&D laboratory. We have a team of experts within our team, and we have a research methodology that allows us to test and fail quickly to improve and grow faster. This is a bit about the roadmap. We have been working over the last couple of years on the technology development. We are currently growing up our production scale to be able to have a capacity of 20 tons per month. And we hope in this year and next year to be able to expand our product. At the end, what we also want to do is to focus on using local resources so we can strengthen those value chains that are here in Colombia related with the agriculture and agricultural waste. So we believe that business can be done differently and can bring social and environmental impact across the value chain, not just for the owners of the business. So this is us. Please follow us in LinkedIn, social media. This is also my email in case you have like any questions. And thank you very much for the invitation.
Thank you very much, Catherine, for the pitch. Really interesting to hear about your approach. And I think we can then directly continue with Jose. And then after all the pitches, we will have time for questions.
Yes, then let me share the screen. Hi, can you see all the screen now? Okay, well, right. Thank you
Yes.
very much for having me today. Thank you for the invitation. My name is Jose Espí. I'm the CEO and co-founder of B0. And my presentation today is going to be about the different packaging solutions or sustainable packaging solutions that we've made from starch and how we are approaching the industrial scale up of our operations. So first of all, I would like to tell you a little bit about B0. B0 is a startup. We were born about 3 years ago with the goal of developing and producing bioplastics from renewable sources as an economic alternative to conventional plastics. And why are we called B0? That's because we have a clear goal in mind. We aim to develop bioplastics of zero impact, which we've defined in a triple goal. So we have 3 goals, 3 big zeros, which are the following ones. First, we'll have zero emissions. That one is the easiest to achieve because thanks to renewable sources, emissions are considerably lower than conventional fossil plastics. And you can always neutralize the remaining emissions with other programs. And then the second zero will be zero pollution. Here we are referring to biodegradability in different environments. That could be compostability, or that could be also in marine water or in soil, depending on the application, obviously. And then the last zero, which is the hardest one to achieve, is being able to offer competitive prices even when it's about fossil plastics. We know that companies are very interested in bioplastics, but the truth is that when it comes to price, that's the main limitant. That's why all our R&D efforts are directed in reducing costs. And what we've done so far is that we've developed a bioplastic compound. And why is this attractive? Well, first of all, it's bio-based. It's made from potato starch. we've been working with first generation biomass, and now we're switching with the first trials on second generation biomass, also from potato. It is compostable at a domestic level. That means that you can throw away our materials with food residues. And thanks to all our efforts in R&D, it's economic regarding other alternatives in the market. The production of our compound is done with conventional technologies. As you can see, we use a double twin extruder to produce our pellets. And we use starch and obviously many other different elements to obtain the final product, which is this compound, these pellets. And this compound is directed to the flexible packaging industry. The first pilot or product that we are testing with potential clients is a net for potatoes made out of potatoes, and also the compostable band that you can see in the image. So that will be everything made out of potato starch. But also our compound can be transformed into different flexible packaging applications, such as film for the kitchen, or plastic bags for supermarkets, or carrier bags, or even mailers for shipping. That's what we've been doing for the last 2 years, and as of 2024, we are expanding our range of products into a new a range of semi-rigid or rigid bioplastics that can be done also from the base that we've developed from our TPS. TPS is the thermoplastic starch that we've developed. And these applications are mainly targeted as in compostable containers or boxes, cups, lids, but most importantly, and what I want to highlight for everyone, is that how we work is usually with a client behind. So what we do are co-developments, so tailor-made developments, formulations to satisfy the needs of every client. Oh, sorry for the noise. Can you hear me now? Yeah. So sorry, 1 second. Yes, I was mentioning, sorry, I think the noise is, can you hear me now?
Yes.
Okay, perfect. So as I was saying, we use conventional technologies for the production of our materials. This is an example of the pilot plant, or a picture from the pilot plant where we work. This is the compounding, and once we've made the compound, we've moved on onto the conversion, which is also done with conventional technologies. This is an example of blown film. So it's basically same machineries, same equipment, but obviously we need to change the parameters. For instance, our bioplastics operate at a temperature degrees of 140, 160 degrees. And when it comes to results, after a few years of many mistakes and many learnings, we've come to develop a bioplastics with a high strength. As you can see, our bioplastics, which will be sample 3, the one in blue, it achieves a strength of 45 megapascals, which is quite significant for the application that we were targeting. And where are we right now as a startup, as a company? So we are scaling up our operations. That means we're moving from pilot plant to industrial production. We've successfully scaled up the production of film. We've produced film twice in industrial setting, and we've done also the first production of compounding. And we're gonna move next couple of weeks in the production of different products, such as the net that I showed before. And how do we do all of this? Well, we're a very small team. We're only 3 people. I'm a PhD student at Oxford University, where I study how to scale up these sort of operations. I'm I'm in charge of all the business part, all the financing, and then we have the core of the team, which is Christina and Sophia. Sophia is my colleague who also spoke at the previous webinar here. They are the experts in formulation, compounding, and biodegradability, and we obviously work closely with many different research institutes such as IMPLAS. And yeah, that's very much most of what we do. I'll be very happy to answer any questions later on.
Thank you very much for this nice presentation.
Thanks to
and
you.
Also thank you very much for keeping the time. And yeah, I think the floor is yours, Nori, now.
Thanks, Annika and Suke and everyone here. Wait for a minute, I will share the screen. Okay, good day everyone. Thank you very much for having me today. I'm Nori, co-founder and inventor of BioPack seaweed-based packaging. Indonesia is an archipelagic country and the second, if not the first, biggest seaweed producing country in the world. Though we use less than 20% of our ocean, we are the biggest. Ironically, the seaweed farmers live in poverty and have been vulnerable to human trafficking since some decades ago. If we could contribute to increasing seaweed demand, we could improve the livelihood of seaweed farmers and set them free from poverty-induced human trafficking. Therefore, I chose seaweed to make bioplastics in 2011, around 12 years ago. So in the previous webinar, it was discussed that the problems with seaweed-based bioplastic are the scalability and the price. We know that not all inventions and research outputs can be scaled up to commercial scale. Here, I would like to share the great news from BioPack that we have overcome those two challenges. We have proven that we can scale up our production capacity. We transform our research output from laboratory scale to pilot scale, and with the funding supports, awards, and prizes we won, we have further scaled up from pilot scale to commercial scale. And we could produce our products at the most affordable price among all brands of seaweed-based bioplastic. Our products are available as sheet, sachet, gazette, pouch, drawstring bag, and then also grip hold bag, and now we are producing also a continuous sheet. Our products stand out because we are truly sustainable, biodegradable, and compostable. And our sachet, gazette, and pouch are vacuumable for sausage packaging, for example, and could be attached with a degassing valve for roasted coffee bean or coffee powder. We have the most advanced technology to process seaweed into continuous sheet to be applied in automatic sachet filling machine and to replace cling wrap for household usage. We also have developed seaweed-based ink that is compatible to our packaging and paper. We are ready to provide seaweed-based palette to our partners who want to make their own product packaging. These are 5 main patents that I have. The first patent was registered in 2011, granted in 2015 about biodegradable bioplastic and the most practical of their disposal. The second patent was registered in 2012 and granted in 2016 about edible bioplastic. The third patent is about seaweed-based capsule to increase seaweed demand and to overcome the current challenge in the pharmacy industry. Then the fourth and the fifth patent were registered in 2019, granted last year about flexible packaging for various applications. The certificate of conformity is a confirmation that our product has passed the test against 219 substances of very high concern. After Japan Food Research Laboratory tested our packaging to ensure its food safety, they released a food packaging certificate. Before I established BioPack in 2019 and launched the product in March 2020, I had a halal certificate and acute toxicity testing certificate that showed our product had the highest level of food safety. Our products are safe to be disposed on soil and water. It doesn't need any specific facility or treatment, and it is safe for the microbial diversity. Due to the limited time, we will not present BioPack for all applications, but we will choose some samples to represent some use phase. Our seed is applicable for various sectors such as food, personal care, and retail. Then our sachet is designed to replace small format conventional sachet that are worthless to recycle and use as single-use packaging. Our continuous sheet are provided in two variants regarding their intended use. The first is to fill the product using automatic sachet filling machine, and the second to replace the cling wrap for household usage. Then the business process is aligned with SDGs, and we can provide SDG reports to our customers. Thank you for this time. And we are looking forward to any collaboration and, of course, to the questions and feedback here.
Thank you very much for your presentation. And then we are heading to the last presentation of today by Anmol.
Yes, am I audible to you?
We can hear you, yes.
Yep. Yes, I'll share my screen. Is it visible to you?
Yes, we can see it.
So first of all, hello everyone. Thank you for giving me this opportunity. I'm very thankful to Team Prevent Alliance. So I am Anmol Bhatia, the founder of Bank Biopolymers Private Limited. We are dedicated to advancing. Sorry. Hello.
Go on, please. I hope everyone is muted now. Thank you.
Okay. Sorry. So basically, we are advancing sustainable polymer solutions using agriculture residues to combat plastics pollution. Welcome to our mission-driven endeavor for a cleaner and greener future. So basically, I will tell you about the problems we are facing in all over the world, the impact of common plastics on the environment. The expansion of traditional plastics presents critical environmental challenges from climate change to water shortages to waste and pollution to microplastics effect on soil. It's a very huge effect of present of plastic, conventional plastics on the earth. So urgent action should be needed to transition towards sustainable alternatives to elevate these pressing issues, right? Additionally, what we are attacking here is we are also attacking the stubble burning problem, the paddy straw burning problem here in India, basically in North India, where burning of paddy straw, also known as parali in Hindi, a major source of pollution in Northwest India. This year, 23 million tons biomass has been burned by farmers. So we are also attacking this problem. These burned releases greenhouse gases and pollutants into the atmosphere, significantly deteriorating air quality and posing serious health hazards. Right. So here at Bank, we have a breakthrough technology. What we do is we procure paddy, agriculture waste paddy from farmers, process it, compound it to make it into granule forms. These granules from the extrusion machines are supplied to the industries where injection molding and compression moldings are being held, and we make product out of it, and they make product out of it. We also generate revenue and profits while making a positive climate impact and providing a sustainable substitute for single-use plastics. Our bioplastics granules crafted from agriculture waste serve as a sustainable substitute for single-use plastic and plays a crucial role in curbing pollution from incineration of agriculture residues, also replacing single-use plastics. These versatile pellets, right? These versatile pellets can be processed and molded just like traditional plastics because they have the same characteristics as of traditional plastic, or you can say conventional plastics, offering a wide range of applications in various industries. From your cutleries to packaging to blown films, you name it, we have a compound for it out of agriculture waste. So bank biopolymers plays a pivotal role in mitigating climate impact by offering eco-friendly alternatives, reducing the incineration of agriculture waste, decreasing the pollution, decreasing the pollution and the use of single-use plastic, and contribute to a lower carbon footprint in the polymer industries. So basically, what I want to say is like they have a very low carbon emission when prepared as compared to conventional or petroleum-based or fossil-based plastics. Our commitment to sustainability extends beyond plastics, shaping a greener future for generations to come. Let's compare our material with conventional plastics available in the market. So our material is starch-based, or you can say agriculture waste from cassava starch and sugar cane and paddy straws and cacao also. Our bioplastics composed primarily of consumes 48% less energy in manufacturing compared to conventional plastics, as I have said earlier. Additionally, our manufacturing process don't use any toxic chemicals, ensuring both environmental friendliness and higher thermoplasticity. Our blend exhibit a degradation period from 180 days to 365 days, depending upon the demand of the customers. Importantly, samples made from our granules demonstrate no degradation or alteration in material stored in it, and underscoring the reliability and sustainability of a solution. So in conclusion, I want to express my gratitude for your attention and interest in Bank Biopolymers. We are very much happy to be collaborate to any of the present juries and present team. And you can always mail us on bank.co.in and we have our Gmail account as well, bank.business@gmail.com. Thank you very much. Thank you.
Thank you.
I would also like to get any questions if you have, please. I will be available for the session.
Thank you, Anmol. Thank you all for this very great insight in your circular solutions. And I think we really saw a lot of real local solutions as using seaweed or cacao, sugarcane, potato starch, or even paddy straw in India.